Okay, in this video we're just going to have a look at some factors that can change and the impact it can have on a reversible reaction that's at its equilibrium. If you are unsure about why these things are working, please go back and watch the videos on Le Chatelier's principle, and that will explain the science behind it. Okay, I'm going to use the Haber process as my example for my reaction, and a couple of things we need to be aware of: that in the forward direction, the Haber process is exothermic. That means it is going to release heat, energy, and that means that surroundings will become hotter. It also means that in the backward direction it will be endothermic. We can also look at this and we can say there are 4 moles on the left hand side because there's 1 mole of nitrogen and 3 moles of hydrogen, and there are 2 moles of ammonia on the right hand side. Okay, so let's have a look at some of the conditions and what we are going to do. I'm just going to use 2 sheets of paper to help me here. So the first one is we are going to look at increasing the temperature. Okay, so if we've got this reaction at equilibrium and we increase the temperature, what happens to the position of the equilibrium? Well, the equilibrium, if we do this, the reaction is going to try and lower the temperature. And in order to lower the temperature, the equilibrium is going to shift in the endothermic direction. So that's going to be working in this direction. So the position is going to go to the left, or to the endothermic side in this case. The attainment of this, how quickly this is set up, whenever we increase temperature, we will cause this equilibrium to be established in a far shorter time. So it'll be established faster. Okay. Second condition we're going to look at is pressure. If we increase the pressure, or if we increase concentration in this reaction, then what we need to look at here now is the number of moles. And if we increase pressure, this reaction is going to try and lower the pressure. And to lower the pressure, it's going to move to the side that has the fewer moles on. So the equilibrium is going to shift to the side with fewer moles, which is going to be the right-hand side in this example. In terms of attainment of equilibrium, again, if we increase pressure or concentration, we will increase the speed that equilibrium is established. It will be established faster in a shorter time. Okay, and the final condition that we're going to look at today is having a catalyst added. Remember, catalysts speed up reactions and make them go faster. In this case, position of equilibrium is unaffected because a catalyst will speed up the forward and backward reactions by the same amount. So the position doesn't move to the left or to the right because the forward and backward reactions speed up by the same amount. What it does do is it causes the equilibrium to be established faster. So this equilibrium that we've got here would be set up in a shorter time if a catalyst is added. Okay. As I said, if you're unsure how we've got from the condition and the position of the equilibrium, go back and watch the video on Le Chatelier's principle, and that will explain that thinking to you.